We're gonna go ahead and get started. Thank you guys for showing up early. Most people typically tend to trickle in a bit later, but it is what it is. We don't really have too much to cover today, content-wise. So our goal for today, this is Module 3. This is really our last module of learning CAD. The next two are gonna be applying your knowledge into printing and designing your final project. So we've given you kind of a plethora of tools to just about make anything that you would need in CAD. We try to teach you some of the more generic, more common tools. Obviously, right, we can't cover everything in a 5-week course. So I'd highly encourage just messing around with Fusion. There's a few more things that you may find hidden in the menu that you may want to use. But we've shown you plenty enough that will get you very, very far. So our goal today is to show you a couple more advanced subjects that are going to help you kind of complete the knowledge that you need to wrap up this final project. So the first thing we're going to talk about is assemblies. I'm going to open up a web page for this. So everything that we've been doing so far in this class has been very simple designs, right? We've made a block, we've made a hammer, we've made game pieces, right? Very simple designs that only consist of one part, right? So what happens whenever you get to designing more complex things, right? So as you can see here in this image, there is this very complex race car with tons and tons of parts, right? There's all the wheels, you have the seating, the steering wheel, you have the suspension in the front, the engine in the back, right? There's probably over 100 parts in this file. So what do you do when you get to something this complex, right? The big no-no is designing this all in one file, but instead, right, the methodology is to design everything individually. And then it's called an assembly file. So you then import everything into one file, and you start to piece it together like a Lego. And that's going to be our first assignment, right? We're going to be building Legos to kind of show you how to piece things together whenever you have separate components in Fusion, right? So as you can see, we are going to be working with some more complex things that really can't be made in one sketch. That's when you're going to be using assemblies. So before we jump into this assignment, actually, let me see if I can pull this up. This is a little bit simpler. This is a project that somebody did this last semester, and I think it does a good job of exemplifying exactly what we're talking about, right? So this is a piston cam system, and although you could design this in one big Fusion file, it's probably not the best idea. So what this person did was, on a separate file, they designed the pistons. On a separate file, they designed the connecting rods. On a separate file, they made the pins, the crankshaft, the component, and then they made one big file and combined them all together, right? It kind of saves you time, because if you're going to have copies of things, you can just copy and paste them in there instead of having to design the thing 4 times, right? So the goal here is complex things with multiple components. We make assemblies where we throw all of these files into one and we piece them together. So instead of jumping into the Lego project immediately, we're going to do a bit of an easier demo. So if you go over to our Slack, I have a zip file of building blocks. This is your first assignment, and we're going to pretend like we're 3 or 4 years old and build a little building block tower out of cubes and whatnot. So I'm going to show you generally kind of the approach to take with making assemblies, right? This will be a really quick, maybe 10-minute example. I think something like this is learned best just through practice. I can sit up here and talk, but you're going to learn way better if you're able to do it yourself. So I'm just going to show you the interface, how to combine multiple parts together, let you guys play with it a little bit, and then we'll let you guys move on to something that's a little bit more advanced, which is trying to build a little Lego car. We'll give you all the files for that. So if you want to go ahead and download the zip file that I gave you with the building blocks, right, it's going to look something similar to this. Let me find it. Okay, so I do not have the file on my computer. It seems like I deleted it, so I'm going to show you actually how to import these files. I realize that's something that we have not done. So I'm going to go over to the Slack, and I'm going to download the building block assembly to my computer. And then we're going to move over. You'll notice that it is a zip file. So you cannot import zip files into Fusion. It's going to corrupt. There's no data for Fusion to take. So make sure you unzip it. Where you do this does not matter, right? You just want to download the files to your computer, unzip them so Fusion can read them, and then we're going to move over to Fusion. And on the file icon in the top left, we're just simply going to go over to upload. Select files, and then we're going to grab all those files that we just downloaded to our computer. Right? This works very similar to your file explorer on your computer. So where do I want to save it? We will save it to just my general CAD training file, and we'll push upload. You'll see it'll take a little bit to download. So as I'm sitting here waiting, you guys can do this along with me. Okay, so we've downloaded all of our files to our Fusion. As you can see, they're all right here. Something really weird that I really don't like is whenever you download files, it doesn't give you a preview, right? So you're gonna see these orange cubes. There is no way to preview the part, which I really don't like, but I mean, it is what it is. So to start an assembly, you have to create a new file and save it, right? You cannot put parts into a file that is not saved. It's really weird because whenever you start a new file to make an individual part, right, you don't have to save immediately. But anytime you start an assembly, the first thing you have to do is save it and name it. So I'm gonna go ahead, make a blank file, and we're gonna save it. I'm gonna name this building block assembly practice. And now we can start putting parts into here. So how you do that is with your file open on the side, it's as simple as grabbing an object and dragging it in to Fusion. I think they're still downloading. Nope. There you go. So some of these are still downloading. The first one didn't work. But what you can do is you can grab a part that you've already made, right? So step one would be making all these parts, right? They have to be done in separate folders. You then make a new file, you save it firsthand, and then you can go to the side and drag parts in, and now you can start combining them together. So you'll notice you have this big movement block in the middle, right? You can move it up, down, left, right. You can rotate it as you'd like. You can do as you please. If you ever exit out of it, and you want to move it again, the button is right up here under Move Copy, so you can select that, and then just make sure you move over to Components, select what you want to move, and you're free to move it around. So, rule of thumb, the first thing you always import into a assembly file should be kind of your base, right? So if it was a car, it'd be your chassis. For this tower, it's going to be the first block on the tower. And what you want to do is you want to ground it, right? You don't want things to be moving around, so the first part you're going to ground to the center of this file. So you can right-click on the first part that you import, and you're going to go over to ground. And it's now locked in place. We can't move it up, down, left, right. And now we can start building a tower. We can start placing blocks around, on, left, right of it. So I'm going to open up my data panel on the side again, and I'm going to go ahead and import another file into here. All right, so this one's going to be a rectangle, and they're always going to spawn in the center. So right now, this really isn't too good. They're clipping inside of each other. So go ahead and grab any of these movement functions and just kind of get it out of the way so we can now see that there's two separate boxes. Okay, so we have a rectangle that is undefined in free space, and we have a red cube that is defined in space, right? It's centered at the origin. So to constrain these things, right, to constrain two objects to each other, we're going to go up to the joint button, which is right up here. And I'll leave it on the screen for a second so you can see exactly what we're doing. Joint works pretty similar to the constraint tool that we used with sketches, but this is for assemblies, right, with solid bodies. And what we're going to do, you'll see there's a couple functions on your screen, but what we want is going to be to use the simple tool. I'll explain the other ones in a second, but what simple does is it allows you to make relationships between like the Cartesian axes of both of these. So we'll say, I want this point of this green block, right? I don't know if you can see, but there's a little XYZ delta on my cursor. I want this point to be in contact with this point, and it'll snap it on, right? So we're giving it a rule. These 2 points come in contact. And then you have things as offset and rotation, right? So if I want to move it a little bit over here, right, we can add an offset in that way, offset in that way, and you can also rotate it at an angle if you would like. Additionally, sometimes you may not get what you want. There is a flip button down here. So what flip will do is it will mirror it across the axes. So if you get something that you do not want, my first recommendation would be to push the flip button. Most of the time, it's going to fix it. If not, maybe just take a step back, do a little bit of thinking, and figure out what's going on. But now, whenever we push OK, right, these two are constrained to each other. The middle one is locked in because we told it was fixed, and now the green one is locked in because it has a position relative to the red one. If I go back down and edit my joint, if I go over to motion, there's some pretty cool stuff you can do here. We're not going to get into it, but if you were going to make like a piston system, right, you could add movement. So like, for example, here's revolution. We can make it rotate around the axis. We can make it slide around the axis. But to emphasize the point that I'm getting at, if we go to rigid and animate, you'll notice that they're stuck together, right? We gave it a property that tells it what we want these two things to be in space. So push OK. And that's pretty much the fundamental of what we are doing here, right? I'll do it one more time in case you didn't catch it. I'm going to drag another cube in. So this time we'll do a triangle. We're going to move it out of the center just so it's easier to access. And then we're going to go over to joint and apply some sort of location restraint to these parts. So maybe this time I'll do the center of this back triangle to this part right here. And then we can push OK. What these other options do, and this will be the last thing I'll say, again, while you play around with this for a little bit so you can become comfortable with it. So what simple does is it allows you to pick points on the outside, the outside faces of these bodies, right? Notice how I can't click on the inside of this triangle. I'm solely restricted to clicking on the outside. If you wanted to get an inside part, the second option is going to be between two faces. So if I wanted to get the midpoint, you can see I can now start selecting on the interior of the part. It's just a little bit of extra knowledge to know. Not too crucial, but for most instances, you are going to be using that simple function. Again, we'll give you guys like 5 or 10 minutes. This is a really, really important aspect of Fusion, right? As soon as you start getting out of making baby parts and you start making more complex things, right, you're going to have to throw things together. And understanding this thing really well in and out, it's going to help you fly through this. So you can download the zip, start playing around with it, maybe throw 3 or 4 blocks together just to make a tower. Try to experiment and see if you can break it, figure out the ins and outs, and then we'll get back together. We'll show you how to download the zip for the Lego, and that one's a little bit more complicated. That one requires a lot more thought than just simple building blocks, but we'll get there when we get there, and I will start the timer. I don't care. You're fine. Class or something, or you just left?
Yeah.
What'd you have?
It was like a 263 meeting because a lot of people have fucked up their financial analysis.
With like the boss?
No, not the beyond the.
No, like the boss, like your boss. One
My
of the
lab
professors.
coordinator, yeah. Lab coordinator and professor.
Yikes.
Bro, people are getting ROR is like 2%.
What is it supposed to be?
It's like in the 3 to 50% at least.
30 to 50?
Yeah.
Oh, there's something back there too. Yeah, he came in and grabbed it. He didn't ask me anything about it. It's gonna break as soon as he puts weight on it.
I'm surprised you didn't comment on it.
What was 2K assignment for you? Oh, 2K1 exam.
No, oh, like 60 or 70. I don't know.
That's what even I'm expecting.
That's what you're expecting? Yeah, I didn't know how to do 1.5 of the free responses. And then there were like 2 questions where like I got an answer, but like it was really iffy. I don't know. So I don't feel great about it. But
Yeah.
whatever, what can I do?
I think I messed up the one for your response with the time constant one.
What'd you get?
I got 2.5.
What did you heard?
5.
5? I got 1/5.
Did you do L
L
over
over
R?
R, yeah. My R was 6, and my L was 30.
That's 5.
6 divided by 30.
No, 3 divided by 6. Because
Wow.
L was
I
30.
swapped it.
No.
I did R divided by L.
I don't think you're gonna get points cut off on that. You might get like 2 points cut off.
Well, I'm hoping 1. Damn,
I mean,
how did I do that? That's so embarrassing. Unless you play. Okay, so it seems like most of you have already kind of gotten bored of this assignment, which is totally fine. This was supposed to be an introduction. So what we're doing next is kind of like the big brother assignment to this. So in the same fashion that we did this, right, you can go to our Fusion, or you can go to our Slack, download the zip file for the car, and using this image, we want you guys to piece together this car using joints. It's a little bit more complicated, like I said, right? We're not using building blocks, so you're gonna have to use a little bit of intuition of exactly what parts are touching when the car is assembled. If you need any help, of course, call us over and let us know. But we're just gonna extend the timer to give you guys time to work on that activity if you still want, and this one. It's so much better. I think joints is one of the things Fusion does horribly. I hate it. Yeah, SolidWorks does it. It's not what I use.
It's like I feel like with especially like selecting edges, because I remember when I first like started CAD
Mm-hmm.
and I did like assemblies, I was like, I'm gonna need some on the edges, and then I would add like fillets and like chamfers later, and then all my mates would just like die. And I feel like I have to do that for you too. Like I think like there's a better way, but like I'm not sure.
One of my classes, thermal average.
Oh God. How did you do?
I got 100.
I hate your shit. What was y'all's average though?
68.
See, I would have been. I did bad. I don't know how I did so poorly. Kind of upset about it.
Like walking out, I knew like I did.
What did you do on the first one?
First one 90. I fucked up the one conceptual question that had 6.1 increased degree on the first exam.
95 exam average. Jesus. I have an 80 average in like class of my exams.
I hate shit on my last Calc 3 term. I'm about to eat shit again.
Yikes.
How was Calc 3?
It's an online. I did not want to take it, so it's an online. just leave it up there if you really want to.
This cap is like open though. Take Oscar.
Just a little advice. I would highly recommend doing everything one by one. So bring one piece in, ground it, and then bring a second piece in, attach it. Try not to bring all of the parts into the file at once. You can, it'll just get really hectic. So my recommendation is just slowly go one by one. As soon as you finish putting 1 and 2 together, put 2 and 3 together, 3 and 4, and so on and so on, instead of trying to do it all in just one big step. If you're using the online editor, that was horrible. You're the original owner, so you should use it in Word. Yeah, I think we need to attach a sample. Yeah, and like watermark it or something, because a lot of people are submitting the screenshot of the sketch finished. So I mean, like, they didn't really specify, but like, somebody could easily go in and just add a dimension to everything, and like close out of the sketch and you can't tell. It's black. Like, is it black because of what I already used? So I think, it's too late to penalize. That's our own fault for not elaborating properly. But I think to just clear up even more miscommunication, we should watermark like a sample submission and attach that. seems like everyone's doing fine, but you guys may need more time. So I'm just gonna throw another 7, 8 minutes. Don't want to leave you guys with work to do out of class. So we'll give you more time to do this. I'll add 10 minutes to the timer. And if we need more, again, we're not pressed for time, so keep working at a good pace, and we'll keep adding on more time as we see fit. Additionally, I want to add, so as you start working through the project, right, you may start piecing 2 pieces together, and the joint is going to move out to the side. It's going to assemble the joint there. To be truthfully honest, I'm not too sure why it does that. The whole point of grounding it is so that everything goes to the middle. But if you make a joint and it just kind of floats off to the side, you can push OK, and then once you push OK, it'll actually put it in the right position. My guess is that it does it to kind of give you a better angle of it, right? It's away from all the action, so you can kind of focus on exactly what the joint is. But yeah, if you panic because things are going in the wrong place, like the completely wrong place, just press OK. If it's good, it's good, and if not, maybe you need to do a little bit more troubleshooting. But that is a little weird visual error, visual bug, just so that you're aware of it. That is so bad. I refuse to. I absolutely refuse to.
Like, not only is it so much slower.
Makes you like 5 times as efficient. I feel like it's so much harder to do anything.
Frustrated.
When I took a CAD class in high school, my professor was like, the hierarchy is trackpad, mouse, and there's actual like spheres. It's like a plugin. Let me see if I can look it up. CAD sphere. Yeah, like these. They're super expensive, but it's literally just like a flight Joy-Con, and you plug it into the side of the computer, and you're able to rotate. You push it in for like zoom, pull it out for zoom, or push it in for zoom in, push it out, or pull it out for zoom out, and then you can rotate it this way. It's insane, but yeah, they're super expensive. They're really
Yeah, not
expensive.
$150.
But I mean, hey, if you do it for a living, maybe you want to spend $200 on a CAD scan or whatever they're called.
True,
It's like
true.
CAD mice. They're
Business
super cool.
expense.
Yeah, they're really cool. We had some in my high school, so I got to play around with them. It's really hard having to relearn it, but yeah, they're pretty cool.
When my high school had CAD classes, but they were like very simple. I think they just started doing them, so there was not a lot going on.
We had nothing, and then we just hired a new professor who had been teaching at his old school for a while. He came to the school but loved the program, so we hired him. He came over and like brought our engineering program from like 0 to like amazing in like a semester, which is insane. I was like, I've seen this assignment before. It was mine. Yeah. I don't think you were there that day exact, but I was like, yeah, we need to make up homework assignments. And I was like, oh, bro, I looked at it, I was like, bro, this was such a pain. I was overlooking all the material before this class, and the repository that we were going to use does not work.
Which one?
The I don't this one. Actually,
I sent like a bunch of them.
oh no, you only sent me one.
Oh,
Yeah, so you need to make an account to log in. I tried to make like 3 accounts with 3 separate emails, and it didn't let me log in.
They know what you did. They would
I was gonna recommend some CAD examples, but I see that they have some reason to make them screenshot the whole screen, just so that they can see that it was made by them.
in the parking lot on a weekday. That's for faculty.
Yeah, I think it's fine, so long as they grab any file from anywhere. I think GrabCAD might be a good bet. I really like GrabCAD.
Did you do it on this one?
Thermo? Yeah. Yes.
So that you got a haircut. I died laughing, bro.
Yes. What did you tell your barber? Yeah, that one doesn't work. Yeah,
No,
so,
like-
so like I said, you have to make a account, but the accounts don't work. It's that's how they all work. You have to make an account to download files like that. But yeah, there's no way. Like I said, I think I mean it is a homework assignment, so yeah, obviously kind of explore different repositories and see which ones work.
Wait, let me see. Wait, so did it let you make that account?
Yeah, let me make the account, and then whenever I went to push download, it said sign in, and I would try to sign in. I didn't even get that far. We didn't get to the download button. It just said sign in. I would sign in with my credentials that would be saved to the computer, so it's autofilled, and then I would push login, and it would tell me this account does not exist or something. I did 2 different emails. I checked my email to see like a verification email sent me. Nothing.
It's so weird. Because this is like the same company that made SolidWorks. So like should be
Yeah,
like
I
good.
noticed the icon.
Yeah.
It's the same one as the SolidWorks.
I think this one didn't require an account.
Okay, can you send that one in?
Yeah.
Oh, check, the policy. But yeah, send that in.
I can like there's so many.
Even SolidWorks works.
STL works too.
Yeah, can you send that into assignment and then make a note about what extension? Double check it first. Make sure which of those step files works. So there are 3 extensions. Make sure you have the correct one. And then I'll send in the one that I found, which is on GrabCAD. So they can use either or. I don't know, if you can take care of that though, and the remaining minutes also, do not grade the assignments. My bad, I should have told y'all. There's like maybe 10, 20.
Did you get that message from
Yeah, forward to y'all. I just told her to text y'all because I wasn't gonna do it. I was gonna forget.
I think the assignment was fine. Because you were driving.
No, you're good. The wrong way of submission's cool. I knew y'all read it during this session, so I wanted to send it over to you guys. What was I gonna do? All right, so we're gonna move on to the next assignment. Seems like everybody's got the gist of it. So if you haven't finished it, again, we're always gonna have time at the end of class, so you can wrap it up there. So we're gonna move on to another really cool tool, and that is the Canvas tool, right? So I feel like a lot of art in general is just kind of copying and modifying from other people, right? You can always make stuff from scratch, but you're always gonna take inspiration from outside things. So a cool thing that you can do in Fusion is you can actually import pictures as a plane, right? So instead of having the solid yellow planes that we see right here, you can import a picture as a plane. You can kind of trace over it to give you a good foundation. So this is a project that was made like a semester or two ago. It's a Wally figure. Turned out really, really great. One of my favorites. But what you can see is what this person did was they imported a picture off of the internet, right? So they found this picture off of the internet, and they were able to kind of trace out the outline, right? So like the eyes is a pretty obscure shape. I mean, Wally's just kind of a box with legs, but the eyes are kind of strange. So if you wanted to kind of take an easier way out instead of trying to make that complex shape, right, you can import images and trace over them. And if I haven't mentioned this enough, this is one of my favorite features of Fusion. It's this little play button down here, and it allows you to kind of see the sequence that you've taken to make this model. So for a basis, right, you don't know where to start, importing pictures to Fusion and just kind of tracing over them is a great way to begin. So I'll play this little video. You can see exactly what they did, right? I'll play it again just in the beginning so you can see exactly, right? We put an image in, we want to get the basis of it, and then from there, we'll build off. So this is a really cool feature. A lot of people use it for their project. People who want to make really artistic things, right? You can always make it from scratch, but if the resources are already out there, such as photos, why not take that photo and use it to your advantage? So back in our Slack, we have a photo of the engineering fountain right here. So what we're going to be doing is we're going to be making the engineering fountain, right? Again, it's a pretty obscure shape with the curve, and we could try to model it ourselves, or we could take the photo in, we can begin to piece apart and recreate parts of the fountain, and then since it's two-dimensional, we'll make a revolve. So the first step, again, go to our Slack and download this image, and then we're going to pull over to Fusion, and we're going to import this into one of our folders so we can edit it. So this is my CAD training folder. This is where I've been saving everything for this course. Earlier, we went to File and Upload. Additionally, there is this really big, nice Upload button at the top of your screen. So this works too. You can push Upload, select Files, and then we're going to go and grab that image that we used earlier, right? So we're going to pull in and import our engineering fountain into Fusion. So how we start is we are going to begin with a new file, right? So blank file named untitled, and under assemble, one second. Okay, here we go. Under insert is canvas, right? And this little description says exactly what I had said, right? It allows you to insert an image as a plane that you can use to trace for reference. So we're gonna go to canvas, and we're gonna pull in our image right here. And then we're going to choose where to attach the image. So we'll snap it right here on this plane, and it is very, very tiny. So we'll go down, and we will scale it up, I think 50. There we go, much better. So we applied a 50% scale, or a 50 times scale to the X and the Y, and we have a nice photo of our engineering fountain. And now we can use this to our advantage to make something that's a little bit more complicated. So what we're going to go ahead and do is we're going to create a sketch right there. And we are going to make this part right here. If you notice where my mouse is, we're going to make this whole right section of the engineering fountain. Again, we are tracing it. It's not going to be perfect, so we're going to try our best to freehand sketch. There is no way to kind of project this geometry, right? The Fusion's not going to be able to tell where the outline is, so we're just going to have to do a rough job sketching it. So we're going to start off with the straight lines, and then we'll get to the curve part, which is a little bit more complicated later. So again, just roughly tracing over this right hand of the engineering fountain. We're going to zoom in to the top, complete that line across, and then we're going to go all the way down and complete this line down here. Again, does not have to be perfect, just get a general basis, and then we're going to keep going across until we have this part done right here. Now we have this little arc point right here. I don't know if any of you know this, but the engineering fountain is actually modeled over, I believe, the e to the x function. So we could use a circle, but that really wouldn't work, right? Because it's not a constant radius, right? The e function linearly grows. So we're going to use, we can't use an arc tool, right? Constant radius, we can't use a circle tool. So we're going to use, under create, there is the fit point spline tool. And how this works is you're basically going to go along the path, which is this right here, from this top point down to this bottom point, and you're just going to place a good amount of points. And what it's going to do is the more points that you put, right, it's going to approximate the curve that is being created by those points. It'll create the function, and it'll smooth out that whole curve. So the more that you put, the more refined that it'll become. And you'll see when we start to do this. So fit point spline, again, that was under create, under spline, fit point spline. We'll click here, and then we'll zoom in, and we are going to have to do this linearly. Again, we have to do lines, but the more points that we put, the lines will start to arc out and make this more obscure curve. So we'll make a point there, and then we're just going to keep on zooming along the line and just placing more and more as we see fit. So whenever you get to the end, make sure, I'm pretty sure if you push escape, this is one of the weird tools where if you push escape, it deletes it. There's a cool little check mark on the bottom. Click that, and that will close off your line. And if we highlight it, you'll see, right, we now have this nice curve that outlines that perimeter of the engineering fountain. So really quickly, we're going to go ahead and do this part down here, doing the same method. So we're just going to quickly trace out the straight parts. And then we're going to use the fit point spline to get this arc part. And again, the more points that you put, the more precise this arc is going to be. And we'll just keep putting them, you know, maybe here, another one here, just to fill out the shape. Just like that. So in this case, generally we don't want to leave it blue, but we are tracing over it. So in this case, it'll be fine. We'll leave it like this. We're going to go over to finish sketch. We're going to turn off our canvas just because it's kind of in our way. And then we're going to go ahead and extrude this part right here. So we're going to go to extrude. We'll select our two bodies. And what we're going to do is afterwards, we're going to do a circular pattern. So what I don't want to do, right, is you can notice our sketch is right here on the y-axis. So if I go ahead and extrude it this way, this sketch is going to be, actually, I'll go ahead and do it right now, right? So let's say we extrude it like that. I'm going to go ahead and do a circular pattern. We'll do it around our middle. And we'll do 4. You'll notice that these are offset, right? They're all on the left or right-hand side of the line. That's not really what we wanted. It looks more like a pinwheel than a circle. So what we're going to do is whenever we get to this extrude function, right, there's lots of really cool things hidden under these drop-down menus. We're going to go from one side to symmetric. And now it's going to be based around that center line, and it's going to be fully symmetric. Now when we make that circular pattern, everything's going to be centered on the X, Y axes. So any number's fine. In this case, we'll do 1 inch. And then we'll go under create. A cool thing is many of these tools apply to both bodies and sketches. So you'll notice in one of the first assignments, we did a circular pattern for the gear. So there's a rectangular pattern and a circular pattern that exists for bodies, right? And then if we go make a new sketch, you'll notice there's another one that exists just for sketches. So many of the most popular tools are going to have two versions of it. There's one that exists for sketches. There's one that exists for bodies. For example, another one is the fillet. There's a fillet option right here, and there's another fillet option right here. So you're often not constrained to the way that you do stuff because there are multiple stages at which you can do these steps. So we'll go under create, as I've been saying, and we're going to go to circular pattern, and we're going to copy these two parts around our center for 4 times. That's about half the assignment. If you want to go ahead and look at the slides or the grading rubric, there is a little bit more to the assignment. You'll have to add the details to the engineering fountain. So I'd recommend, again, going back, adding the detail to the original sketch. Whenever you pattern it, it'll copy forward to all the other faces, and then just go ahead and make a nice base. And that is this assignment. As usual, we'll give you time. This was the intro, right? The stuff that we haven't taught you. The rest you already know how to do. So just again, go into the slides, go into the grading rubric, and see exactly what parts we left out. Add those, and then you'll be done with this assignment.
I can try something really quick. So,
All right. Yeah, no, it's
okay, great.
totally fair.
I can you only use the thread tool on the whole, so I guess like
Right? Well, no, but if you sketch a hole,
oh can you will it still like put it on next to the cut?
Oh, so you're saying you don't have any of the things on the bottom, so
I
you
can't.
can't grade any of it?
Well, no,
Well you can grade the hair dryer.
no, yeah. What I'm taking out prices for that. There's no flooring.
I think there is. It's just
Is it?
really, really tiny. Again, that's why you need the whole screenshot. No, you're good. Do this exactly, and then again, if you want to get put any of you guys to fix it up. No, you're totally alright with that. That's completely valid.
I thought she would
Message. Oh, she was.
Have you gotten that message sent out? Can you send that out first? Because we're almost done here.
.com and spit out an STL. And it's like should be good enough.
No, I don't know if the ones are gonna work with that because of how it works. That's like a surface. The other one that you had,
selecting edges, right?
the other one that you had was fine. Let's do that one. I don't want to mess around with.
Because okay,
Let's
so,
turn those like a.
so this one works.
But
I just need to create an account.
That's
I
totally
don't-
fine.
I
All
don't
of them
know why-
require you to create accounts.
Yeah, I don't know why it didn't work.
Yeah. So. Oh really? Send all 3 of them in. I'll send the grab CAD one. You send the 2 in that you found. I'll wait for you to send your 2 in because we're done. We're gonna do the YouTube video for the plane assignment again because I think that worked really well this time.
So, did she ever like ask for something?
Yes, I took care of all that.
She didn't resubmit it.
So you also want to select messages. I'm keeping the forms open for the rest of the semester, so if it's gonna get resubmitted, it'll get resubmitted. Like that's not our fault. Like let them take care of that. That was our original policy, and I that was like yeah, it's stupid. Well, no, like the thing is, like the reason we do that is so that they stop. It's to like reduce the amount of like volume of messages of turning in late stuff, but all it does is increase it. And additionally, like I mean, we've all been super busy lately. I've done this every session where I take it away and then we just put it back. So it's only fair. I mean, it doesn't do us any extra effort, I guess.
She
should have access to catch course material. Well, you guys have access to it, so
Let me send it here.
yeah. Send the links in there, and then yeah, put what file extension they have to use. Actually, can you? A lot of people aren't here, and they're probably not gonna watch the video. Put like a paragraph saying the homework assignment is to go to any CAD repository and download building blocks and complete like a make set space. Here is a link to some model repository. So just give like an intro to what you're saying. What? No, okay. What are you doing? Again, I thought you got. Did you not learn your lesson the first time?
I did, but I also figured out to do Rob to Twitter.
I understand the photo is super detailed. You don't have to go crazy into detail. Obviously take it with a bit of salt. Don't do the bare minimum, but you don't have to do everything. Just do enough that it looks like there's a good enough amount of details. It's been a while since I looked at the image. I forgot how many little pockets there are, but just a good amount would be fine enough. No.
Okay, but you know what's also interesting? So that's what I want to talk to.
Alright. Who's this is? Just sitting right there. And Colton, there's one over there. Here's the head. enter.
Yeah.
The amount of times I've accidentally sent messages is embarrassing. Check the rubric for more details. Yeah, that's cool. I like that one. It's awesome.
I'll write a message saying that you'll probably have to make an account to download the files.
Alright, so we still have 45 minutes left in here. So what we're gonna go ahead and do is just kind of finish up the lecturing class, or the lecturing portion of class, and then give you guys the rest of the time. So there's one assignment left, which is making a plane. So making a plane uses this tool in Fusion called the Form Tool, which works like, the way that I like to make an analogy to it is you kind of throw a block of Play-Doh into the middle of your screen, and you use like the movement tools in Fusion to push, pull, squeeze, rotate, to kind of morph that initial block into something more complex. Right, so with something with like a plane like this, it would be pretty difficult to use a combination of sketches and extrusions to make. This aspect of Fusion is really, really cool. A lot of people have used it on the project, but it's completely separate from all the stuff that we've learned. Milestones has been running this course for quite some time, and instead of me sitting up here and lecturing this, this part takes a very long time, unfortunately. In the Slack, I've attached a YouTube video, so if you just want to play the volume out loud in here, headphones, go back. The assignment's very straightforward. I think the guy who taught this session about 2 summers ago does a way better job of explaining it than I can. It's very intuitive. He's basically going to walk through the process of opening up the mesh section of Fusion, how to import a base shape, and then it really is just like playing with Play-Doh. You just kind of have to get a little bit creative of, okay, I want to make nose cones. Let me grab this part of the mass and pull and pinch and squeeze. And again, we're running a little bit low on time because the assignments take so much time. We always try to do the lectures to show you the stuff that we haven't taught you. But again, like I said, I think this person does a way better job than I do. So if you want to use the last 45 minutes, again, we're always here to answer your questions. I would watch this video and do the assignment in class. If you think you might struggle on it, we can come over and help you. Of course, just finish up the engineering fountain and Lego car assembly. What we're going to do in the meantime is we're going to send out some information about the final project. The fourth of pass is only allowed a week, but I see as to why we shouldn't do that. We just never thought about it. So I'm going to quickly compile up all the slides for the final project. And if any of you want to go ahead and get started, it'll be due in like 2 weeks, which is way more than enough time. Most people do it the night before, honestly. But if you want to put a lot more effort into it and make something really nice, if you've seen up here, right, we're going to make all these for you. We'll print them out and let you keep them. So if you really want to make something cool that's going to sit on your desk or make something functional like phone stands, you'll have 2 weeks to do so. So we're officially done with the lecturing. Like I said, in the last assignment, there's a pre-recorded video that I think does a really good job. If you guys have questions, come ask us. And then for all the information that you'll need for this session and the next one, we'll send out and the homework. So the homework builds off of the Lego car project that we just did. I've taken multiple CAD courses at different universities, high schools, whatnot, and building stuff out of Legos always just seems to be the standard for playing with assemblies because it's just easy, right? You need to have lots of intricate parts that can be put together. So like we could build a car, but we have to find some repository, or we have to make the car ourselves to piece it together, right? Legos are super easy. You can find them online. So this final project just goes a little bit further. This final homework assignment goes a little bit more into depth with assemblies. Instead of giving you a file and letting you make that, we're giving you repositories. So as I said earlier, with the Canvas tool and just art in general, I feel like there is a lot of, not so much copying, but relying on other people for reference and assistance. So there's lots of really cool repositories that are basically just free access public domain websites where people will upload their projects and you can download them to your computer, edit them, tweak them, use them. So there's lots of people who in their spare time as a hobby will make Lego bricks, and they're just free on the internet to download. Some people, I think there's a whole website that allows you to get them as an STL and print them. You can print your own Lego sets, but there are tons that allow you just to import them into Fusion and piece them around. Again, you can read the description of the homework assignment. It tells you exactly what's going on, but our goal for that is to get you familiar with some of the more common repositories around CAD, right? So this is taking other people's projects and kind of using them for your own, and getting more involved with the assembly tool. So that's all we have for today, and thank you guys for coming.